Oh, excuse me. In 2.1, they were talking about reasoning, deductive reasoning, how can you come up with an idea. There was something in there called a conjecture, and they talk about this term a lot. Conjecture, all that is an educated guess. You look at, it's like your hypothesis testing in science. It's just an educated guess. Think of it as you're looking at you're just looking at a situation, coming up with an idea of what's going on. It's really, 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 really easy. After that, they brought in the idea of pattern recognition. They talked about that in, it's like, what's the 15th number in this sequence? What's the 15th shape? Or I think some of those problems were like that. We actually do that in Algebra 2. And I just got done doing that last week with my honors kids. There's this number that you guys don't know about called imaginary number. And there's a pattern that happens with these as well. Every fourth power, it turns itself over into sequence. Oh, all right. You guys know that you can't take the square root of a negative number. You guys, when you guys did that with your quadratic stuff before, you just say no solution, you went on your own merry way. Well, in bearer of bad news, we're doubling the amount of numbers here on that. There's also what's called imaginary. So you can do work with those. Not this year, but next year you will. But what happens is, over time, this pattern develops. Every fourth turn, this happens. So you use reasoning to figure out, if I was going to say, hey, what is this to the 53rd power? Instead of writing it out 53 times to figure it out, you would identify the pattern and then figure out where it goes in sequence. Again, it's something you guys could do, like you were doing with the shape stuff. So if this repeats every 4, all you have to do is take the number and divide it by 4. Because what you do is you try to figure out how many times does this pattern repeat itself, and then it'll give you a remainder to tell you what number you lined up. So how many times does 4 go into 5? Once. How many are left over? How many times does 4 go into 13? What's the number up there in the ceiling? I always wonder why people look up. And how many are left over? So there's a remainder of 1, which means that would be my answer. And that's how this stuff works itself. Pattern recognition. Obviously, don't worry about those values themselves now. It's just something that you were kind of doing with the pattern stuff. I think they also use the idea of the conjecture for, what was it, 3 segments? Or I think it was like the 3-second lengths or 3 points or whatever, the collinear, where you had to have, I think they gave you values. I don't remember the actual problem, but there's stuff that you can get information and just write a statement out or draw a picture. Another thing they talk about that comes up is what's called a counterexample. It's another new one. Counterexample is anything that just proves what you're trying to show. Definitions, pictures, whatever. Okay? Counterexample is anything that disproves what you're trying to show. For example, I could say this. If you are a teenager and you are 14, is that true or false? False. Why? You can be 15, you can be 16. Right. What you're doing there is you're giving me a counterexample. It's something that disproves a statement. Pretty easy. I mean, it's not bad. Not bad. You can say false. You can be 15 or 16. Also, what will happen is, we'll have an example of this here in a minute, that we like to use pictures and diagrams sometimes to show how things work as well. I think that was kind of all they did in 1, if that sounds right. And then in 2, they started to talk a little bit more about how do you write stuff out, how do you come up with what's called if-then statements. And that's what I'm going to spend on time today. So, excuse me. when we get into this idea of what are called conditional statements, we're talking about this thing called a hypothesis and a conclusion. If, then. Okay? You guys have probably all seen if-then statements in science. If water is boiling, then it's at least it's hot. Yeah. Yeah. I was going to say it was 100 degrees Celsius or 212 Fahrenheit. Is that right? So hypothesis conclusions. I know that you guys have seen these things. This isn't going to be all that bad. For example, you don't have to write all this out. If I want to take a statement, two angles are supplementary if they are a linear pair. And I want to turn that into an if-then statement. I would just put in the words if and then. If two angles are supplementary, then they are a linear pair. Really, 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 really easy to turn them into if-then statements. Something that we do pretty much just kind of in this section. And this is where geometry starts to get a little weird-ish, if you will. This is where we start talking more about logic, reasoning, and eventually, by the end of this chapter, we'll do a couple of small proofs. Basically putting down your string of thoughts in a how do I put it? In a chronological way that makes sense. Yes. Yeah. This is kind of where math becomes wordy, if you will. And it's a little weird. It's different. Okay. So one of the things we do is we're going to start talking about these things that are called conditional statements, and that's your generic if-then. Okay? A conditional statement. That's what this would be. If two angles are supplementary, then they are linear pair. Excuse me. Normally, when we're talking about these if-then statements, we use what are called P's and Q's. You ever heard the old phrase, mind your P's and Q's? There's a song.
It's not my head.
I'm not going to play it. Anyway, there's an old saying that goes, mind your P's and Q's, because it's basically stands for watch how you say something, watch how you're wording it, make sure it makes sense. So the idea here of this P and Q, it's kind of like if P, then Q. If something happens, then something else happens. For example, let's see an easy one. If an angle is less than 90 degrees, then it's a cube. If an angle is less than 90, then it's a cube. What's the hypothesis? What's the conclusion? Yes, ma'am? That's what you call a conditional statement. P implies Q. Okay? There will be 4 of these. Start with a conditional. P implies Q. If an angle is less than 90, then it is a cube. Is that a true or a false statement? That is a true statement. Very good. So whenever we write out these statements like this, I always put down if it's true or false. If it's true, great, leave it. If it's false, then I would give a counterexample. So you have this thing called a conditional, and then what they do is they start moving them around. They move the order around, they call them something different. The second one is called converse. What's that? Exactly like the shoes, but not. So this thing called a converse, I'll come back to it. The converse is Q implies P. Say it backwards. So if you start with your conditional, if an angle is less than 90, then it is Q. If I flip it, what would it be? If an angle is acute, then it is less than 90. See what I'm saying? We just flip it. You flip-flop them. Q implies P. Okay? You just say it in reverse. If an angle is acute, then it measures, or I can say it's less than 90. If an angle is acute, then it measures less than 90. Is that true or false? True. That's also true. Okay. So we have conditional, Q, P implies Q, converse go backwards. Q implies P. Yes, ma'am. The if and then are always still there in the same spots, but it's conclusion before the hypothesis. See what I flipped? Angle is less than 90, then it is acute. If an angle is acute, then it is less than 90. The if and then stay, it's these parts. I'm sorry, the acute part switches. Does that make sense? All right. Now we deal with something else when it comes in. It's called negation. Negation means basically put the word no in it. Not. And there's, excuse me, there's a symbol for that with these things. Not P implies not Q. It's a weird looking symbol. Sometimes they use that. Not P implies not Q. Or sometimes they do a tilde. Not P. I forget what this book uses. I think this book uses a tilde. Yeah. A single squiggly. I think this book uses. I've seen it written both ways. I just wanted to show you guys either one. Yeah, this book uses the tilde. And our old textbook used that upside down 7. So what you do here, this is called the inverse. When you negate both of them, it's called the inverse. Not P implies not Q. So basically all you have to do is you go with your original statement and you put the word not in both parts. If an angle is not acute, or excuse me, not less than 90, then it is not acute. All I did is basically put the word no in both parts of the first statement. Is that true or false? If it's not 90, if it's not less than 90, then it is not acute. Correct. Okay. If it's not less than 90, then it is not acute. True. Are these always going to be always true? Excuse me. And if you look at the patterns, how we did our letters, we did P to Q, Q to P, not P, not Q. What do you think's left? What's that called? I just make up a word. Not inverse. It's so close. It's called contrapositive. Contrapositive. Contrapositive is the weird one. It's just because in the name itself. All we do is just take what we just did, flip it. If an angle is not acute, then and this is where I apologize a lot for my handwriting, because I know it's not that great. If an angle is not acute, then it is not less than 90 degrees. Is that true or false? If the angle is not acute, then it is not less than 90. True or false? True. If it's not less than 90, then it's not acute. Okay. It's weird. It's not common for us to think of math in terms of statements and logic and reasoning, but sometimes it just takes a couple of minutes to figure out to walk through this. Hypothesis conclusion. So your P and Q, think of this guy as this is the original hypothesis, and this is the original conclusion. It's what you started with. Does that make sense? Yes, ma'am. Not. Yeah, just a symbol for no. Math people are weird, as you know, being in my class for a couple of months. They use symbols for everything because words, as you can tell, aren't my forte in terms of writing. So we try to use as many symbols. Because I know the word not is a lot. So, it's pretty bad. Pretty bad. Okay. Now, what happened in this problem, is that you had everything that was true. That's not always the case. Okay? That's not always the case. You think about going back, and we'll just say this one. Remember how a second ago I said that if you are 18, then good morning. What do you want? Say more. Ooh. Ooh. Car's being towed.
Walk slowly, put your hands behind your back.
Do not catch go, do not collect $200. Say it. I love to do that. Ooh. Joke. So we go back to the one we were talking about a second ago. I said, if you are 18, then you are 14. And you guys said, was that true or false? False. What was your counter example?
15.
Right. And that's what you can do. That was your P implies Q. Now, if you flip it around, what would the next statement sound like? Yeah. If you are 14, then you're a teen. Is that true or false? True. Okay. So if you flip it, if you are 14, then you are a teenager. True. If you're 14, then you're a teenager. That's true. If you are 14, then you are a teenager.
Yes.
True. You all right? Just write it out there, okay?
No, I haven't written it out. When you were doing the counter argument, you were false.
Right, because that first statement's false. Then I flip it and it became true.
If you are a teen, then you are 14.
If I write the inverse, I'm sorry, the converse of it. If you are 14, then you are a teen. Is that true or false? True, okay. Okay. Negate the original. Not P to not Q. If you are not a teenager, then you are not 14. That's true. And then flip that one. If you are not 14, then you are not a teenager. Also, correct though. You're not.
You're not a teen, you're not 14.
You're not 14. Then you are not. Correct. That is false. What's the counter example? 15, 13, any one of those. Yeah. A lot of times, you can probably use the same exact counter example for multiple things. It's pretty common. Okay, it's pretty common. Now, I wanted just to kind of use that one as far as words were concerned, because I thought it was an easy one to just kind of roll through. But let's go to one that actually has geometry to it. Okay? Let's go to one that has geometry. Vertical angles are congruent. That's a statement, isn't it? I want to turn that into a conditional statement, which means I want to turn that into an if-then statement. How do I change vertical angles are congruent into something that is an if-then form? What would it look like? What would it sound like? What would that sound like, guys? If angles are vertical, then they are congruent. True or false? Good thing. That's true. All right. Write out the rest. Take a minute, write out the rest. And if it's false, come up with a counterexample. Okay. Whenever you're writing these out, you always go true or false. And if it's false, you have to give a counterexample. Okay. Try that out. Congruent, then they are vertical. Okay. I agree. Q implies P. If angles are congruent, then they are vertical. False. Counterexample. Could you draw a picture? Could you draw, basically what you're saying here, that that's false because you can have angles that are congruent that aren't necessarily vertical. So in my mind, I think of it like this. Yeah. I was just about to draw two right angles next to each other. Two right angles next to each other, they're both congruent, aren't they? I could do that. That works. They're not vertical, they're congruent. Second hour we did this one where I just said, hey, this is 30 degrees, and hey, that one's 30 degrees. Aren't those congruent angles that aren't vertical? There's your counterexample. A lot of times you don't have to write it out in words. You can draw a picture. And that's perfectly legitimate for what we call a counter exam. Right? It's perfectly fine. So if angles are vertical, then they are congruent. If angles are congruent, then they are vertical. All right. Inverse it. If angles are not vertical, then they are not congruent. Make sense? Go back to the original. Not P. Not Q. If angles are not vertical, then they are not congruent. True or false? None of that's false. What's your counterexample? Can't I just use the same one?
Yeah.
Yeah. And that's the point. A lot of times you can just reuse. Don't have to overthink it. There's two congruent angles that are not vertical. Excuse me. And then last but not least would be the contrapositive. Flip it. If angles are not congruent, then they are not vertical. Correct. True. Angles are not congruent. Move this up some. If angles are not congruent, then they are not vertical. Okay. It's the idea. We're using logic reasoning to come up with statements. I know this is probably one of the first times in math that we're not mathing. Really, if you think about it, this is the occasion that you're not mathing with numbers in a sense. We're going to take statements and write some stuff out. I think other than that, that was pretty much what was in those first two sections as you guys were going through it. It shouldn't have been terrible. I know last Friday I had to assign what, like 8 problems or something like that total, 4 from one, maybe 5 from another, so maybe 8 or 9. Add to those ones you did that were supposed to be for today. I mean, obviously, if you didn't get the internet to work right, that's fine. We'll collect all of it tomorrow. But I want you guys to do. I think I wrote it down. I think it's just 3 more, 4 more. It's on 93. So add these problems to what you guys just finished up with on page 93. You got a little bit of time. You'll probably be able to knock it out of here as well. 20, 21, 23, and 24. And we'll talk, we'll go on from there. Manana. Okay. Yes, ma'am. What's that? Last week. What's up? I can't see your screen. There was, if your name is missing on one, there's up there. I go ahead, I give everything back. So, yeah. What do you want? got a mountain